right? This is the type of question that you see on your Aleks, and I just extracted out so that we can go over, so that you guys will see how to do this kind of question. So I will go by a little bit fast, or depend on the problem, but this is what we have, right? So in chapter 11, reminder, we deal with statistic, and this item, they give you the information, they give you the raw data, right? The test score, and they ask you to find the frequency distribution table. Reminder, frequency distribution table is basically ask yourself is between this group of number, right? Between 79 to 80, how many students score in that group, right? So anything between 79 and 83, this is what we do is we say, okay, we have 1, 2, right? 3, 4, 5, 6, 7. We have 7 people, and that is your frequency, which is you have 7 people in, let me write it here. You have 7 people score between 79 to 83, right? And then again, between 84 to 88, how many people we have, which is again, 84 to 88, we have only 1 person, right? We have 1 person here. Between 89 to 93, well, 89, we have 1, 2, 3, 4, 5, right? So we have 5 people. And again, the last over, which 94 to 98, which is we have 2. And one thing that you want to do is you want to add this frequency up, right? You want to add this frequency to ask yourself, do you have the same amount, right? If you add this thing here, everybody see that you have 15 people in total, right? If you add this item, we have 15, right? 7, 1 is 8, 8 and 5 is 13, 13, 2 is 15. And we know that 3 times 5, if you add all of this number up, you have 15. So most likely you have enough people, right? So that's your frequency distribution table, which is you tally them up. And how do you make a histogram? Again, the histogram is very user friendly. You have your hand in your Aleks, you have the hand. The only thing you do is you go to the first group and you drag this number, you drag up to 7, right? You click on this line, there's a invisible line here. You just take the finger and you drag it up to 7, and they draw a line for you, right? In the second group, you just drag up to the 1. In the second group, in the third group, sorry about that. In the third group, you drag up to the 5. In the 5th group, you drag to the 2, right? And again, it's very user friendly. They drag and they highlight it for you, so you don't really need to do anything in terms of that item for your frequency histogram. It's just basically you drag to the right frequency. Okay, and like I say, this thing here, you probably be able to do it without me to go in more detail. So this item here, this is the other item that we have, is they ask you for the percentage of the data, right? They ask you, how do you find the percentage of the student who are shorter than 70 inches? So because they ask you for shorter than 70 inches, this is what you need to ask yourself is, how many data is shorter than 70 inches, right? Again, we cannot include the 70. We cannot include the 70. We only include the numbers shorter than 70, right? So again, 70 is not shorter than 70. So we do not include the 70 in this item here. And as you can see, we only include the number, the data that is shorter than 70, which is I have 1, 2, 3, 4, 5, and 6. Right? So all you need to do is to find a percentage. All you need to do is take the number shorter than 70, which is 6, divided by the total. And if you divide this by the total, you have 0.6. And again, what do you do? How do you find a percentage? You need to move the 0.6, or you move the decimal to 2 places to give you 60%. Or if you take 0.6 times 100, if you take 0.6 times 100, you will have 60%. So again, to find the percentage of the data below or less than or younger than, basically you're looking for the number of data less than that value, divide by the total number, and then again multiply to 100 to convert back to decimal. I mean, but percent, right? Same thing go. We know that the total is 15 professor, and we want to know how many people younger, what is the percentage of data younger than 35. So younger than 35, we know that one professor younger than 35, two professor younger than 35, three professor younger than 35, right? So again, I have only three professors by this is, and if you reduce to 1/5, you get 0.20. And again, convert the 0.20 percentage, you just base the decimal two places to give you 20%. So based on this data, there are 20% of the professor is younger than 30. Again, to find the percentage, you find a number below, divide by the total number, and again, just move the decimal place two places to the right. And again, we did that earlier. We did that earlier in terms of the percentage of the percentile. So you can look over, I think section 10.4 is what that information is in. So now, how do we find the mean, the median, and the mode? We can attack the mode first, right? The mode should be the easy one to attack. And reminder, the mode, this is what you have is you ask yourself what data appear up the most. And looking at this thing here, everybody see that we have two mode, right? What are the two mode? The two mode is number 11 and number 30. So again, those are the two mode because number 11 and number 30 appear up the same amount of time, right? So that's your mode. 11 appear up 3 times, 30 appear up 3 times. Again, it's not 3, but the actual data itself. The other thing that I want to point out, make sure, ladies and gentlemen, make sure that you read the correct question, because sometimes they change it, they switch it on you, and that's where some of you guys will get a little bit frustrated, right? So how do we find a median? Reminder, the median, the first thing, this thing coincidentally is the same, but to find a median, this is what you need to do, is you need to put this item in order first, right? To find a median, we need to put this in order, which is, again, this is my order. And again, my order item, which is -3, 11, 11, 11, 30, 30, 30. And again, because that this is the odd number, I know that there are 3 number to the left and 3 number to the right, which the leftover, the median will be 11, right? That's my median. To find a median, basically I put them in order. And if it's an odd number, the middle number is the median. If it's the even number, I need to add the 2 middle number and divide by 2, right? How do I find a mean? Reminder, to find a mean, you need to take the individual data, which is -3 plus 11 plus 11 plus 11 plus 30 plus 30 plus 30. Take all of that and divide it by 7, right? So again, 30, 41 times 3, 41, well, 43. So you take away 3, so that's 90, 120, right? 120 divided by 7. Again, you take 120 divided by 7, whatever that number is, that will be your mean, right? Your mean is the average. You add them up, divide 120 divided by 7, you have 17.14, right? So again, they ask you how many decimal they want, so 17.1. So that's your mean. Reminder, to find a median, you need to put this item. And again, on the right hand side, you can click the calculator and they give you that calculator item. and that's what you need to do. Looking at this thing here, this is the other one that I think that some of you guys might have problem, is they ask you the list and they ask you to find the sample of 40 middle income, right? And they ask you what is the mean, is the mean number of children per household. So per household, meaning you have to divide it by the household, right? Meaning, looking at this thing here, to find this mean, the first thing you need to do is, because you have a multiple item, what you need to do is you need to take this 2 item and multiply them. You need to take the 8 times the 8 to give you 64, the 14 times the 2 to give you 28, the 3 times the 13 to give you 39, the 6 times the 10 to give you 60. And once you add them up, right, this is what you need to do, is you need to add them up. And if you add them up, this is what you have, 124, 194, 194, so 203. And reminder, once you add them up, 203, again, check my math, I do it on the fly, so I might add in my head a little bit different or wrong. Let me see, 90, I think I added wrong, huh? 90, 80, 170, 180.
I got 191.
191, yeah. So again, if you have your calculator, help me out. I kind of add on the fly, so 191. So the total, when you add them up, you have 191, and then what you need to do is you need to divide it by the total number of household. So you don't divide by the number of children, because they ask you per household. So they not ask you the children, per children, right? They don't ask you the household per children. They ask you the children per household. So you have to add the household together, which give you 30, 45, right? They give you 45 household right here. So you need to take the total number and then divide it by that, right? So this thing here, instead of say 8 plus 8 plus 8 plus 8 plus 8 plus 8 plus 8, 8 times, right? And then plus 14 plus 14, instead of add them individually, we just multiply them, because multiplication is a shortcut to addition, right? So again, this thing tell you that you have 8 of the 8, and 8 of the 8, instead of say 8 plus 8 plus 8 plus 8 plus 8, we just say 8 times 8, right? And instead of add 14, so basically you add them up, or in terms that you multiply them, and then you have to divide by 45. And again, whatever the number came out to be, that will be your mean. Okay, 191 divided by 45. So it's roughly somewhere between number of children per household. So roughly, I think about 7 something, 6 something. 191 divided by 45, right? 4.2, is that right? 4.24?
Yes, 4.24.
Okay. Yeah. So again, that's what you have, roughly 4.24. And because they ask you for 1 decimal place, so at least 1, I think you put 24 is fine. Same idea go for this one here. They ask you for a sample of 25 families, and then again they ask you find the mean number of gallon of milk consumed, right? So again, same idea, because they give you the multiple. This is what you need to do, is you multiply this item, and you multiply this item 65. You multiply the 2 item, which is 3. You multiply the 3 times the 1, the 9 times the 4, and the 13 times the 5, and then you add them up, right? You add them up, and if you add them up, 39, 90, 104, and you divide it by the number of family, which is 25. Right? If you add this number up, you have 25. Those are the number of family. So you divide that roughly 4 something, right? 4.1. 4.16, is that right?
Yes.
So again, this thing here, the two problem, the difference between this two problem is because they give you the group of data and not give you the individual data, right? I mean, for this one here, you can do, because it's only 25, it's only 25. If you want to, yes, you can do this item. You just say 3 plus 9 plus 9 plus 9 plus 9 plus 13 plus 13 plus 13 plus 13 plus 13, right? And about see that you have 1 3, you have 4 9, and you have 5 13. If you add them up and divide by 25, you still get the same thing. It's just that instead of add them up, multiplication is a shortcut. So that's why we multiply it and then add them up. So it's the same. This one here, we can do it because it's only 25. But if they give you like 50 or 100, you don't want to add the individual data. Okay. So that's the only reason why we multiply. So I think this here is where a lot of you guys have problem with, right? They give you this histogram. They give you this histogram and they ask you to find a mean, right? And again, route your answer to 1 decimal place. So this is what we have is they give you this histogram. Instead of give you the individual data like we have up here, instead of give you the individual data, they give you the histogram and they ask you to find, the mean, right? The question is actually find the mean. So in terms of this thing here, we know that there are a total of 74, right? If you don't see that, you can add this number, 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 add this number. If you add those number up, you should get 74, okay? Because that's how many people in this survey. So how do we find the mean if they give you this histogram? Well, before we can find a mean, this is what we need to do, ladies and gentlemen, is we need to, because they give you a group of data, because in this group right here, in this group is between 26, 27, 28, 29, and 30, right? Between these two number is 26 all the way to 30. So what we need to do is we don't know the actual, what is the actual data. We know that between 26 to 30, there are 8 people, right? Between 26 to 30, there are 8 people in this group. But we don't know the actual data, so we cannot just add them up. So what we need to do is for each group, we need to find a midpoint. We need to find a one number that represents this whole group. So we need to find a midpoint or a mid-range of each group. And to find the midpoint of each group, this is what we have to do is we need to take the smallest plus the highest, divide by 2. Or the highest plus the lowest, however you do it. You just take the highest number of that group plus the lowest number of that group and divide by 2. And if you add them up, this is what we have is 56 divided by 2, and 56 divided by 2, you should get 28. Meaning in the first group, we will use 28 to represent my data. And again, all we do is we take 28 multiplied to the frequency, which 28 multiplied by 8. In the second group, you do the same thing. You take 31 plus 35, right? My 31 plus 35 divided by 2. And again, this thing will give me 66 divided by 2 to give me 33. So my second group, we have 33 times 26. My 33 times the frequency, right? This group, I take the 33. I took one number to represent my whole group, and 33 is the midpoint, which is that represent. And again, if you have not seen it yet, you can take this group 36 plus 40 divided by 2. And again, this thing will give you 76 divided by 2. 76 divided by 2, this thing should give you 38. And what do? We take 38 times the 18. And again, if you don't see it, every time you jump from one group to the next, you add 5, which is your class width. Every time you jump from one group to the next, you add 5. Every time you jump, you add 5. This should give you 43. This should give you 58. And this should, 48, sorry. 48, not 58. And again, the next one will give me 53. So basically all I do is I take 43 times 12, 48 times 7, and 53 times 3. So again, this is what we have to do is we have to take one number to represent the whole group. So one number to represent the whole group, as you can see, between each group, that is where your midpoint is. So if you want to find a midpoint of each group, you will eventually get the same number. It's basically, again, what is in the middle of 46 to 58. 50, 46, 50, the middle will be 48. What is in the middle of 51 to 55, in the middle will be 53. And all you do is you take that number, multiply to the frequency that they give you, which is this number here. So again, let me, 28 times 8 should give you 224. 33 times 26 should give you 858. And then 38 times 18 should give you 684. 42 or 43 times 12 will give you 516. 48 times 7 to give you 336, and 53 times 3 to give you 159. And then again, all you do is you add this up, you add all this up and divide by the total. You add them up and divide by the total of 74, and you should get the answer, or you should get the mean. So again, the only thing different between this problem versus the previous one, they give you the individual data, right? The previous one, they give you the individual data. This one here, because of the frequency, they give you a group of data. And basically because of a group of data, you have to ask yourself, I have to choose one number to represent this group. And that's where you find a midpoint. One number to represent each of the group, and that's where the midpoint come in. Okay, so everybody see where my midpoint come in is basically the number between those groups. And again, you add all this item up and divide by 74, you should get the answer. Okay, and again, it's a lot of number crunching. I think after the midpoint, I think you should be able to finish the rest. Question with this one here, ladies and gentlemen. Now, how can you make this item here? How can you, I think this is the other one that you guys have problem is how can you analyze your percentile, right? So this is what they ask you is a national change. So if you read this thing here, a national change of department store rank is 1,100,000 sale person by the monetary value of their sale. Donna sell all at the 32nd percentile. Boris sale is at the 66th percentile. So this is the 2 percentile they give us is Donna is at the 32 and Boris at the 66th percent. So what they ask you is, what of the following are true about Donna? So is Donna's cell higher in value than 68% of the person? You can see that what does the percentile represent? Reminder, the percentile is what position you at. So if she at the 32 percentile, meaning she at the 32 position, she is not, her value is not higher than 68%, right? Because again, if you're at the 32 position, how can you be at more than 68 or higher than the 68%, right? About 68% of the cell person have cell higher than the value of Donna. That might be right. We put a small star there. The value of Donna cell was about 32% of the. Again, can we predict the value of everything? One thing is, the percentile does not give you the actual value. The percentile does not tell you how much you make or what you make. Okay, the percentile only tell you the position of your item. The percentile does not tell you that you make $30 a day or 35. The percentile just tell you you are at that position. Okay, so if whenever the percentile, we cannot convert to the value because we don't know the value, right? They just say they give us some value, we don't know the value. So looking at this thing here, your percentile cannot translate to the value. So looking at this item, the only thing that close to us or close to this item here is, we know that roughly 68% of everyone sell higher than her, right? Because see at the 32 position, roughly see at the 32%, and meaning there are 68% of the other people have higher in terms of her sell. So that's what you want to analyze, right? You want to analyze. One thing is, we cannot use the percentile to justify the value because we don't know the value. Okay. The other thing is, what must be true about Donna and Boris? Boris cell were higher in value. Once again, we don't know. We don't know the value, right? Both Donna and Boris have cell higher in value than the mean. Well, we don't know, and this cannot be. The mean is the middle number. 32 is not above, so it's not higher, right? The value of Boris cell was 34. Again, we don't know. We don't know the value. We don't know the actual item. The value of both cell was in the bottom half. We know that they are not in the bottom half. So now we go back and say, wait a minute, right? So looking at this thing here, which one is the closest, or which one is most true for us, right? If we take the first look, we know that we say, oh, none of this thing here look good. So we know that they are not both in the bottom half. Do everybody agree that we know that they are not both? Because one of them is 32, one of them is 66. So they are not in the bottom half of this item here. So we know we can eliminate that. We don't know the actual value. We don't know the actual value of this item here, so we can eliminate the actual value itself. Right? We don't know how much they make. We know that they are not in the bottom half. So now let's take a look at the first two. The first two, does both Donna and Boris have a higher than the median? Remember, the median is the 50%, right? The median, in the sense, the median is the middle portion with the 50%. So we know that they are not higher, not both of them. One of them maybe, but not both of them. And they are not higher than this median, not higher than the 50%. So now looking at this thing here, we can see that if we have to choose, or if we cross this out and we cross this out, the only thing left that we can choose is Boris cell were higher in value than Donna cell, right? Because why? Because you say, wait, you just told me not to use the value. The actual value itself, we cannot dictate. We don't know how much they sell. We don't know the amount, right? But if you at the 66% and someone at the 32%, you must sell higher, right? In terms of the value, not the actual number, right? We don't know the actual number. Boris can sell $100 and Donna can sell $50, and based on the information, they might be that far apart. But we know that because of the percentile is higher, they must do some extra more sell than the other one. Okay, and again, it's just basically this one here is basically ask you, can you eliminate or can you dictate or identify the result of the, how to interpret your data, how to interpret the information that was presented to you guys. Let's try one more, and well, I don't have one more to try. But I think most of the question is the same. So, take a look at those and see if you have a question, you can send me an email and I can explain it in detail. Now, here come the other problem that I want to focus is the population standard deviation versus a sample standard deviation. Okay, and again, this thing right here is not hard. It's not hard. It's just a little bit tedious. If you read this thing here, they say that the age in years of the 5 employee at the particular computer store are as follow. Assume that this age is a constitute to entire population. Find a standard deviation for the population. So reminder, we went over this thing here. There are 6 steps, the 6-step procedure that we need to do. And again, we went over this thing here. Reminder that the first step is we need to find a mean. And how do you find a mean? Reminder, the mean is the same. You take each individual item, you add them up and divide it by the total. In terms of this thing here, you add 22 plus, you take 22, you add them up and you divide it by 5, right? 22 plus 21 plus 44 plus 29 plus 44, and I believe this thing will give you 5/8. Is it 5/18? Yeah. If you add, not 5/18, sorry, I do the head. It's not 5/18. If you add them up, you divide it by 5. This thing will give you 32 as your mean. That's the first step, is you need to find a mean. This is your mean, which is 32. And once you find the mean, the next thing you need to do is you need to take each of your data minus the mean. You need to take each of your data minus the mean, which is, this is what you need to do, is you need to find a deviation. And the deviation is basically you take each of your data, and in my item, my data is 22, 21, 44, 29, 44. I take the data minus the mean, and this is what I should have, which is -10, -11. This thing will give me +12. This thing will give me -3. And this thing will give me +12. And if you take a look at this thing here, let me change the color. If you have a negative, if you take the negative, if you add all of the negative up, If you add all the negative up and you add the positive, this thing here becomes 0, and that's what we want. We know that there are some data above the mean, some data below the mean, and that's what we have, right? That's the first step, find the mean. The second step is find the deviation, which is take your data minus the mean. And then what is the third step? Well, the third step is you need to take this item and you square them up, right? If you square them up, which is -10 times -10 to give you 100. If you take this item, square them up to give you 121. You take this item and square them up to give you 144. You take this item and you square them up to give you 9. You take this item, square them up to give you 144, which this is your third step, which is you square the deviation, you square them up. And the fourth step, what do we need to do for the fourth step? The fourth step, we need to add them up. And if you add them up, this is where I have the 518 come in. If you add this thing up, you will have 518. And now what do you need to do? Well, remember the fifth step right here, you need to take this item 518 and divide it by n. And in this case, what is n? N is equal to 5. We have 5 employee. You need to take this thing here divided by n. And if you take this and divide by n, you get 103.6. We are not done, ladies and gentlemen, because to find the standard deviation, you need to take a square root, which is the sixth step. The last step we have is we need to take a square root of 103.6. And if you take a square root of this thing here, if you take a square root of this item here, 103.6, you should get 10.178. So probably 10.18, or depend on what they ask you. But this is the sixth step that you need to do to find your standard deviation. You need to find the mean. You need to find a deviation. You need to square the deviation. You need to add all of the square up, divided by n, because it's a population. Because it's a population, you divide it by n, and then you take a square root. Okay. What is the difference? And again, I will go back and take a question if you have question, but what is the difference between the sample, or what is the difference between the population versus the sample standard deviation here? So again, the reason why I go with this two problem is to show you that you still have to do the 6-step procedure. We have the 6th step, and again, same thing go. The first step, we need to add this item up. We need to add this item up and divide it by the total number of items we have. And in this case, everybody see that we have 6 items. We have 6 count, and we need to add this thing up and divide it by 6. And if you add this thing up, divide by 6, you should get 54. Okay. If you take the 41 plus the 53 plus the 52, if you take this and you add them up, you should get 54. And now what do I do with that 54? Well, I have to take the second step. I have to take the 41 minus the 54. The 41, not the 41, 53 minus the 54, 52 minus the 54, 51 minus the 54, 58 minus the 54, and 69 minus the 54. Basically, I take each of my data and subtract the mean. And if I subtract this, I have a -13. If I subtract this, I have a -1. Subtract this, I have a -2. Subtract this, I have a -3. Subtract this, I have a +4. Right? Let me use this. If I subtract this, I have +4. If I subtract this, I have a +15. And again, if you look at this thing here, if you look at the red number, this is 19. And if you add this number up, you have negative 19, which is negative 19 and positive 19. They cancel each other out. And that's where your deviation is good, right? So now what do we do with this number? Your step 3 is you need to take this thing square to give you 169. You need to take this thing square to give you 1 square. And again, when you square, the negative number will become a positive number. When you square this thing here, basically you take a negative times a negative. That's why we have a positive. Is it 225? 15 times 15, 225. So again, 13 times 13, 169, so on and so forth. This is what we have. And then step 4, we need to add all of this number up. You need to add all this number up, and if you add them up, you should get 424. Now, here comes the 5th step. This is the difference between the sample versus population, ladies and gentlemen. For population, at the 5th step, at this step, for population, we divide it by n. But for sample, we need to divide by n minus 1. Okay, so what is the n in this case? The n in this case is I have 6 minus 1. So I have 426, not 426, 424. 424 divided by 424 divided by 5. And again, it's not the same because this problem, I have 6 data. And if a 6 minus 1, that's where I have 5 come in. Okay. And if I divide this thing here, I have 84.8. Okay. So again, this is the difference. This is the main difference, ladies and gentlemen, the main difference. And this is why I ask you, or not ask you, but this is why I put this problem here, is to show you that if they ask you for the population at the 5th step, you divide by n. But if they ask you for a sample at the 5th step, you divide by n minus 1. That's the difference. And now the 6th step, all you do is you take a square root of 84.8. And again, if you take a square root of 84.8, 9 point something, right? 81 is 9, so 84.8, 9.2, 9.208, so 9.2, 2 decimal place, so 9.21, right? So again, that's the idea, and this is the main idea that I want to point out is up here for population. For population, if you look at this thing here, we still have a 6th step. The 6th step is the same. The only reason is now if they ask you for the population, if they ask you for population at this location, you divide it by n. You divide this number by n, meaning the total number we have, the n is here is equal to 5. So that's why I divide by 5. But for a sample, for the sample, I divide it by n minus 1. And n minus 1, in this case, the n is equal to 6. 6 minus 1, that's why I have 5. So it's not the same 5. One of them, I take 6 minus 1. The other one, I take the whole thing. So the population, you take the whole thing, but the sample, you take the n minus 1. Question with this thing here, ladies and gentlemen. Question on how to find the standard deviation for the population versus the standard deviation for the sample. And if you don't have question, I think let's take a look at this item here. The rest should be, well, this empirical rule. So let's take a look at this thing here. This thing, we went over this item. Reminder, your empirical rule. Your empirical rule is you either have 68% within one standard deviation, right? Within 1, standard deviation is 68%. Within 2, standard deviation is 95%. Within 3, standard deviation is 99.7%. So this is what they ask you, or this is what they tell. Let's take a look at this information, right? The information they ask you is the length of the movie file that available for streaming is modeled using a normal distribution below. So this bell-shaped curve is below. The mean of the distribution is 189.4 minutes, and the standard deviation is 20.1 minutes. In a figure, V is the number along the axis and is the highest part of the curve. And U and W are the number along the axis that have the same distance from V. Use the empirical rule to choose the best value for the percentage under the curve and that's shaded, and identify the value of U, V, and W. So first of all, what is V? If V is the highest, reminder, what is the highest? The highest item is your mean. So the V value is easy. The V value is whatever your mean is, that's your V value. So in this case, my mean is 189.4, right? So now they ask you estimate, pretty much estimate how much of the percentage is this, which is you click on this item right here, is dragged out. Is it 68? Is it 95? Or is it 99.7? You have to choose one of them. And if you look at this thing here, you can guesstimate. Hopefully you can guesstimate which one by looking at this item is. Remember, we have this thing here, right? We have a 68% if it's within 1 standard deviation, and we have a 99 point something in this item here. So looking at this thing here, if it's small, you can guesstimate that it's 68%. If it's all the way out here, out here, and they shaded this region, if it's all the way down out here, then this is 99.7. Okay. And again, because it's just the middle portion of this thing here, we guesstimate that this is 95%. So how do I find a value for V, and how do I find a value for U and W? So to find a value, we know, or if it's a 95%, we know that within 2 standard deviation. Okay, think about this thing here. What is the number? Let me ask you, what is the number you should guesstimate? What is the number for W? We know that this is 220 and this is 240. Somewhere between 220, 240, meaning this thing here, do you see that we can guesstimate that this is somewhere between 230, right? Somewhere right there, because it's look like it's between there, right? And if you remember my empirical rule, every time you take a step, every time you take one step, what do you add? You add this much. How many steps do we have to take? Meaning, how many steps do we need to move from one unit to the next? Everybody see that every time I add this number, again, to do this elementary, this is what I showed you guys last time, is you ask yourself from V to W, how many steps you take. And again, if you know that 95%, this is within 2 standard deviation, then all you need to do is, if you want to, this is what you can do, is you take the mean plus 2 times the standard deviation to find the upper limit. And if you find the lower limit, you take the mean, subtract 2 times the standard deviation. If you remember, if you look at the video, if you see what we did last time, that's what we do. All right. And again, basically, if you don't, and again, I will connect all of this to if who you guys confused. Let's take a look at this item here. Let's do 2. So what is my mean? Do you agree that my mean is 198.4 plus 2 times 20.1? Do you agree that 2 times 20.1 will give me 40.2? And if I add this together, what is 198 plus 40? 198 plus 40, do you agree that this thing will give me 239.6? Right? 229, sorry, not 39. 229.6. Agree? So as you can see, what did we guesstimate? What did we guesstimate W? W is between, that's justify our answer because 229.6 is somewhere between this two number, right? Between the 220 and the 240, that's where my 229.6 come in, right? And again, because we say that it's 95%, that's why it's within 2 standard deviation. And this is what we have is 229.6. And how do I find the U? Remember, if we go to the left, we need to minus the item. And again, that's where we have this item right here. We have the mean 189.4 minus 2 times the standard deviation. And 189.4 minus 2 times 20.1, which 189.4 minus 40.2. And if you subtract that, your item should be equal to 149.2, right? And again, 149.2 is between 140 and 160, 149.2. And that's what we have, or that's how we determine your U and your V. Okay. And again, let's take a look. I thought I have another one. Did I have another one? No, I don't have another one, guys. Again, if one thing is, if you determine for this particular problem, if you determine that it's a 68%, then instead of the two right here, if you determine that it's a 68%, then you will use 1. If you determine if it's a 99.7, then instead of the 2, you will write a 3. So everything is the same. It's just that instead of the 2, you write a 3 if it's 99.7, or instead of the 2, you write a 1 if it's a 68. And again, you know, it's very clear for Alex for this type of problem. The graph look very clear. You can see that if it's small, it will be 68. If it's big, it will be 95. If it's like it's cover everything, almost everything, it will be 99.7. Okay. And let's take a look at this last thing that I think that you guys have problem is they ask you that suppose that the mean for the blood pressure for a woman over the age of 70 is 132 millimeter of mercury, mmHg, millimeter of mercury, with the standard deviation of a millimeter of mercury. Suppose that this thing is normally distributed. Again, normally distributed is basically tell you that it's a bell-shaped curve, right? Normally distributed with the mean and the standard deviation. Approximately 99 0.7% of women over the age 50 have the blood pressure between what two number? So remember, what is 99? What is 99.7? 99.7 meaning this thing here is within three standard deviation. And to find within 3 standard deviation, this is what we need to do, is we need to take the mean plus 3 times the standard deviation, and we need to take the mean minus 3 times the standard deviation. And if you look at this thing here, we got the mean. They give us the mean. They give us the 133 or 132. And if we add 3 times the standard deviation, in this case, we have 132 plus 24. You can see that this is what we have is 156. And this is your upper limit, right? This is your higher number. If you take the mean 132 minus 3 times 8, and again 132 minus 24, and if you minus this item here, you should see that this is 108. 108, which is this is the lower limit. The smaller number is your lower limit. And looking at this item here, between what two value? Between 108 all the way to 156. Okay, so those are the two value that you want to type in, or those are the two value that you have in terms of this thing here, because they give you 99.7%. Okay, between this is 108 and this is 156. If they change this, instead of saying 98, 99.7, if they say 95, the only thing changing is you will say, well, if it's 95, instead of a 3, I will write a 2. Instead of a 3, I will write a 2 here. If they say 68%, if they say 68% instead of the 2, I will write a 1. That's it. That's the only thing different between the 68, we use the 1, the 95, we use the 2, and in this case, the 99.7, we will write a 3. Approximately how many is in between 116 and 148? Again, between approximately how much? Again, this is the middle, right? The middle is 130, 132. Do you agree that every time you jump, which is if you go down, you minus 8, you minus your standard deviation. Again, how do you find this number? Everybody see that if you subtract this 8, 132 minus 8, that will give me 124, right? 124. And if I minus another 8, that would give me 116. So you can see, or you can expect that if you add 2, right? If you add 2, you will get 148. If you subtract 2, you will get 116. So this thing here, because we go 2, because there are 2 standard deviation. If you in doubt, guys, if you in doubt, you can always do this. You know, one easy way you can do is do all 3 of them. One easy way, if you want to, you can do all 3 of them. Let's say that 68% is the mean plus 1 times the standard deviation. The mean minus 1 times the standard deviation. And if you do a 2, 95% is basically tell you that the mean plus 2 times the standard deviation, and the mean minus 2 times the standard deviation. So if you want to, you can do all 3 of them, and then you see what range they give you. What is the range that you have? Is it a 1, or is it a 2, or is it a 3, right? So again, we know the 3 is this much. We know the 3, we got the range, we did it, we find out. Now, if you want to, you can do the other 2. And if you see that the range for the other 2 is this range. And again, this range here, if you do it, this thing right here will give you 124 and 140. 140 here and 124 here, and that's not what we have, right? And again, we have 116 and 148. So we know that it's a 95%. So if you want to, you can do it that way. Do the 68, the 95, and the 99. And let's try one more, right? This one here, similar to that. So if you want to, like I say, if for instance, let's say you say, I don't know what they asked me. Let me do all 3 of them. Let me do the 68. And again, the 68% reminder is the mean plus the 1 time the standard deviation, the mean minus 1 time the standard deviation. So if you do this thing here, you have, what is my mean? My mean is 32, my standard deviation is 4. So 32 plus 1 times 4.1, which is 32 minus 4, not minus, plus this thing will give me 36.1, right? And again, 32 minus 1 times 1.4.1, which is 32 minus this number, and if I minus this thing will give me 27.9, right? 27.9. So if I see that we have is it 27.9? Minus 9, 31. 27.9, right?
Yes, that's right.
This one is 36, sorry. I added 4, but I did not add it. This is 36.10. 32 plus 4, that's 36. So we got this, right? I mean, if you do this thing here, you can see that, the 2 number they give us is right here, right? 27.9 and 36. So we know that this is 68%. Right? And then you can do the 95%. And again, the 95% is all you do is you take the mean plus 2 times the standard deviation, and the mean subtract 2 times the standard deviation. And again, we don't need to do this because of this problem. They asked us for the 99.7, which is, again, we take the mean plus 3 times the standard deviation, and the mean subtract 3 times the standard deviation. And again, if you do this thing here, we have 32 plus 3 times 4.1. So 4.1, you have plus 12.3. And if you add this together, you have 44.3. So that's your upper limit, 44.3. Your lower limit will be 32 minus 12.3. And if you subtract this thing here, you have 7, 9, 19, 19.7, right? So again, your lower limit will be 19.7, your upper limit, so this number will be 19.7, and the upper number will be 44.3. So if you want to, for this problem, if you want to, this is what you can do, is you can do the 68, the 95, the 99.3, because that's what your empirical rule say. Your empirical rule is 68%, 95%, 99. And again, you do it, and then you ask yourself, what is the range that they give me? If they give me between the range of 23.8 and 40.2, then that will be 95%. Okay, so again, that's what we can do for this particular problem. And let's take a look at the last item you have, or the last item. We did a lot of this thing here. We did a lot of this thing here, ladies and gentlemen, and reminder, For this particular item, they ask you to shade the region, right? They ask you to shade the region, and the one thing that you need to do first, if you got confused, is the first thing is you need to select this item here. So they ask you to shade the region under the standard curve to the left of z of 0.2. So z of 0.2 on -2. First, you need to choose the line. So you need to draw a line first. So you need to drag to -2 and you draw a line, and then you choose the second is you choose a shaded region, which is the shaded region they just shaded to the left. So that's what you have to do in the process, is you need to draw a line. If you don't draw a line, they shade the whole thing. If you don't draw the line first, they just shade the whole graph. So you need to choose to draw a line first. And once you choose draw a line, then you choose the shaded region, okay? So now the second item is easy, right? They ask you to use the table. If you click on this table, the table they give you is like, they give you a bunch of number. They give you the bunch of number. And again, what is the area to the left? Reminder, life is good when they ask you for the area to the left, because anything in the chart give you the area to the left, right? So again, the chart might be different because the chart I give you earlier, or the chart that we did earlier, do not have some number, but this chart here have every digit there, every number. So you click on the chart, they have you that item. Okay.
Mr. Turner, I have a question. If it's asking for the right, do we take the number and subtract it by 1, correct? If it's asking for the right?
Yes.
All right, just making sure.
If they ask you for the right, remember, we don't subtract the z. We take the 1 minus the area from the left, on the left, right? So again, reminder, those are the 3 questions they ask you, right? If they ask you on the left, life is good, right? Whatever the number in here, whatever the area is, that's your answer. If they ask you for the right, then we need to take 1 minus the area on the left, which is whatever this item is. Whatever this item is, we subtract that. And if they ask you for in between, you just take the higher area, the bigger area minus the smaller area. And we did this last time. You can look at the video from last time. And again, the last thing we have, or the last thing that you want to do for this particular problem is, again, reminder, is very similar to what we did before. The only thing we need to do is you need to convert your data to become the z-score. And reminder, the z-score is basically you take your data minus the mean divided by the standard deviation. So again, this is what you have is the same. You have to ask yourself, are you looking for the area to the left or the area to the right? This thing here, they give you the mean of 72. They give you the standard deviation of 25. So we got the mean, we got the standard deviation. Now they ask you is more than, right? So again, we know that this is what we need to do. We need to find more than anything to the right. And if we find anything to the right, remember, we need to find the area and then take 1 minus that area, right? But before we can find that area, you need to convert to the z-score, which in this case, the z-score is my data is 109 minus the mean, which is 72, divided by the standard deviation, which is 25. You find this z-score, you find the area in your chart, and then you take 1 minus that. And again, the only thing that they ask you is also they ask you to write your answer in percentage. So you need to convert the answer to your percent. Okay, they give the answer into decimal, but in percentage. So looking at this thing here, again, we did this item last time. It's very close. It's pretty much the same. It's just that you need to convert to the z-score first. Okay. And again, I think you can handle this item. I don't think is give you guys any trouble. It's very close to what we did in class on last Thursday. So let's see. I am a little bit over